All right, so here we've got this example. Again, talking about how we can maybe use graphics, graphical representations to develop a table, and that table allows us to create patterns, okay? So just kind of reading this through to you quickly. It says you want to set up an aquarium and need to determine what size tank to buy, okay? So the graph shows tank sizes using a rule that relates the capacity of the tank to the combined lengths of the fish that it can hold, okay? So that's like a true thing. Like I bought my daughter a fish tank for her birthday, and like you can only have it. You go to I go to Petco and I try to buy fish, and they say, how many do you have? And I tell them, and then they say, like, how big is your tank? And you tell them, and we can't sell you any because your tank is too small for having like 7 fish or something like that because they're collective growth. So this is a legit thing. So if you want to buy 5 2-inch platies, how do you say that? 4 1-inch guppies, 3 1-inch loach, which is the smallest capacity tank you can buy, a 15-gallon, 20-gallon, or 25-gallon, okay? So to use a table to find a reasonable answer. So what I want to do here is I want to figure out kind of like what we did up here, okay? We're going to talk about what our input is, okay? And then we're going to have a process column and then a output, okay? So let's see here. So my input column is going to come from this chart, okay? This chart is a linear graph that basically is going to allow me to create some input-output comparison. So just going to make our table here. And our input is going to be the combined length of fish, okay? So I'll just write length, but that's going to be the combined length. This middle column is going to be our process or our rule to get the output, which the output then is going to be the capacity or the number of gallons of the tank that we're going to need to buy. And what's happening here is, if we think about what's going on in the graph here, we look at the gallons on the left-hand column, the y-axis essentially, and it only goes up to like 12 gallons. Okay, so if you think about the question that was being asked, it's saying, do you need a 15-gallon, a 20-gallon, or a 25-gallon? So the table or the graph that's provided doesn't allow me to make that argument yet. Does that make sense? Like, if it was a bigger graph, then I could just go over and up and say, right there, I need this many, I got this many inches, this is how many gallons I need, okay? We can't do that yet. So what we need to do is take the information that is in the graph and convert it over here. So our input is the combined length. So first thing, and it might not make a whole lot of sense because of the scenario, but I'm going to look at this value right here. We'll zoom in a little bit for us. Okay, if I look right here at the combined length of being 0 inches, okay, which would essentially be 0 fish, right? But if I have 0 fish, do I really need an aquarium? No, so that's why it might not make a whole lot of sense. But graphically it's saying if I have 0 inches, I need 2 gallons, right? Does that make sense? So my input for this first one is going to be 0, and the output, the number of gallons I need, would be 2. And now we're just going to go through the graph here and collect similar data. Okay. Now you can go to like 1 inch, 2 inch. You can go very kind of systematic, but because it's linear, I can skip things and the pattern is going to be okay. So if I go to like 2, so I go to 2 here, how many gallons do I need? 4, right? Does that make sense? So I'm just seeing where that vertical line of 2 touches the graph, and then I go over and see what is that Y value that I need. So 2 and 4. So I fill that into my table. Let's go out to 4. So 4 inches gives me 6. And we can keep doing that. So I'll do that. 6 will go to 8. So what I like to do, guys, it's not 100% necessary, especially if the data is in a line like this is. But you see how my input has a pattern of 0, 2, 4, 6? Like I didn't go 0, 2, 5, 12, right? Okay? Because if I do that, there's no structure that allows me to easily see a pattern in the output. Okay? If I would have gone like 0 to and then 3, and then I would probably go to 6, and then to 9, and then to 12. Does that kind of make sense, everybody? So as we are trying to determine a rule of what is happening here, okay, it makes sense to develop a pattern there, okay? It also makes sense that that pattern is in like chronological order, okay? Meaning starting at the smallest number and moving upward, okay? Like I wouldn't want to go 2, 0, 6, and then 4. Does that make sense? It'd be the same data points, but they're not in order, okay? So that would be hard to recognize a pattern. So what am I doing from my input, that first input, to get that first output? What did I do? What's the algebra between those two things? Start with the input and, as you agree, that I add 2 to it. Okay, automatically eliminate, because I have 0 as my first input and I have a non-zero number as my output, it automatically eliminates multiplication, right? Because 0 times anything should give me 0, right? So there's no multiplication here. It has to be addition, so 0 plus 2. Now let's just make sure, does that rule continue to apply to all of these other options? If I start with that 2 and add 2 to it again, do I get that 4? Okay. Do I get the same thing if I start with this 4, add to it again this 2, does it give me 6? Okay, so my hope is that you're seeing that if I were to take this all the way down to n, okay, so in inches, I would be taking in inches and adding what to it? Adding 2 to it. And that's my rule. That's my rule to determine ultimately how many gallons of water I need. Okay? So now for our specific case, they say we need to determine which is the best tank for us, 15, 20, or 25. Okay? So based on our desire for fish, we need 5 2 inches, right? 5 2-inch platies, or however you say that. So that's 10 total inches right there, correct? So keep a running total here. We got 10 inches there. There's 4 inches. So we got 4 up to 14. And then 17, right? So 17 is the specific N value that we're looking at for our situation. Does that make sense to everyone? So if I start with 17, and then go 17 plus 2, tells me 19 gallons, right? So what is the best tank for me to buy? It'd be the 20-gallon, right? 20-gallon one, right? Okay. Let's say that I would have gotten let's say that 19 would have worked out to be like 16. Okay, so maybe I get rid of that 3-inch loach thing, whatever that is. Okay, and I would have had 16 as the number of gallons, right? Which would have been the best answer? 15 gallon, 20 gallon, or 25 gallon? Still would have been 20, right? Okay, because anything less than that won't hold that amount of fish, right? okay, or won't do it safely. So we have to, well, and in this situation, because of the context of the problem, you ultimately have to round up to the next tank. Okay, we cool with that? All right. So some of these questions, obviously, like they have the story to them, they have context to them, but some are just like this. They're just essentially graphics that show you, rectangles, circles. Sometimes they'll get down here to the bottom and they'll completely take out any context and just give you the input and output values, and we try to determine what the process is. Okay, so this here, what I want to do, the way this is set up is that it's much like that toothpick one. Okay, so I'm gonna call this figure 1. This will be figure 2. This will be figure 3 and 4. So when we set our chart up, our input is going to be the specific figure. So we'll have 1, 2, 3, 4, and eventually all the way down to N. Okay. Middle column will be process again. And the last column, output, is going to be number of circles. And when you do these charts, like I've seen textbooks that will put the input in the first column, output in the second column, and then the process determined at the end. So those things are kind of independent. They don't have to necessarily go in that order, but our textbook in Math Excel will have this process column in the middle for the most part. Okay, so in figure 1, we have what, 1, 2, 3, 4, 5, 10 outputs. Okay, in figure 2, we got 15. Figure 3, we're going to have 20. Figure 4, 25. You guys agree with that? Okay. So now this one's not as direct as what the ones in the past have been. So we're going to have to do a little bit more critical thinking here. A lot of times people like to think the easiest thing is to figure out adding, right? So if I start with my input of 1, how do I get to 10 by adding? That'll be 9, right? So that's a process that makes legitimate sense for that first relationship between 1 and 10. But if I do that in the next one, is 2 plus 9, does that give me 15? No. So that's not the process. So that was a little bit of trial and error, but it doesn't work. Okay? Any ideas on what I could do to get from, so if adding is not working, okay, so I heard you say multiply by, I can't hear very easy, 5, okay, so I'm going to take my input, multiply by 5, so if I multiply by 5, what's that going to give me? 5, right? So then how do I go from that product of 5 to 10? Add 5 more, right? Does that make sense? Okay. So you're going to take your input and multiply it by 5 and then add to a 5. So does that happen then in the second one? If I take 2, multiply it by 5, and then add 5 to that, does that give me 15? And it does, right? So we're on to something. Let's see if that works for 3. 3 times 5 plus 5. 15 plus 5 gives me 20, so that works. Try 4 times 5. That's 20 plus another 5, 25, so that works. So what is the thing, as we're going through here, just kind of highlight this. That there is the same as that, same as that, same as that, right? So the thing that is changing are those, right? Well, when something changes, it varies, right? So when it varies, that's going to be represented by the variable. Okay, so this is going to be 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times the variable. And we're letting the variable be n in this case, so 5n plus then 5. And that's my rule for determining, let's say I keep this pattern going out and we draw out 100 figures. Instead of, and I want to know how many circles are in that 100th figure, instead of having to draw everything out, I can just now say, well, 100 times 5 is 500, plus 5 is 505. So if I draw that pattern out to the 100th figure, I'd have 505 circles in that figure. Does that kind of make sense? Yeah, so once I evaluate the process, is it going to equal the output? Yes. Does that answer your question? Okay. Yep. All right, so same thing here. Now, think about what's going on here. So when we looked at this one, this original one, initially, just by the picture, we are adding things from figure to figure, right? So hopefully, thinking about figure 1 compared to figure 2 compared to figure 3, we know we're adding, so it's going to either be addition or multiplication that are our kind of governing operations, right? When I look at the next one, are we removing squares from figure 1 to 2 to 3 to 4? So now what operation are we probably thinking about here? Subtraction, okay? So we're going to have our input, which is figure 1, figure 2, figure 3, figure 4. We'll have our process. And we'll have our output, which is the number of squares. Hopefully my handwriting gets better. It's been a while since I've used this thing. If you can't read something ever, just let me know. So we got 4 by 4 by 6. So 1 gives me 24, right? 2 is then going to give me, just removing one block here. So second figure is going to have 23. Third figure has 22. And the fourth figure has 21. Okay. What are we doing there to get from the input of figure 1 to the output of 24 blocks? Jenna? Take a minute. Think about it with your neighbor. See if we can come up with anything that makes sense to us. So you're saying, start with my input and, discuss real quick amongst, just be careful the way you phrase that. Because you said input minus 25, right? So you want 20, because you want to write the sign, so you go 25 minus 1, which is my input, right? And that gives me my 24. And then 25 minus my input there, that gives us 23, right? Okay. 25 minus 3, give me that. 25 minus 4 gives me my 21. So the thing that's changing, like you said, was your input. So it'd be 25 minus n. There's my process. Now what's going to happen here, because it's subtraction, like if I ask you how many squares are going to be in the 25th figure, how many are there going to be? Because n would be 25 in the 25th figure, right? So 25 minus 25 would give me 0, right? So this, because it's dwindling, like eventually I will have no blocks up there. So I can't have like a 26th or 27th or 28th figure, because what does a -1 or -2 blocks look like, right? Okay. No homework tonight. Have a great day. Bring that tomorrow. We'll finish those last two tomorrow.